Hello, am I audible? Please just confirm. Anyone, please? Okay, good evening. Okay, thank you. Okay, that's nice. So we'll start within 2 minutes. Maybe other participant will join. So I'll wait 2 minutes more. So today we are going to solve the assignment 6, week 6. Okay, so let us start. So today we are going to solve the question number week number 6 and also the assignment 6. So we have, I'm going to solve your 2025 set. Then I have 2024 and 2023 also. So let us see the question number 1. In open channels, the specific energy is the total energy per unit discharge. Option B, total energy measured with respect to datum passing through the bottom of the channel. Option C, total energy measured above horizontal datum. Option D, kinetic energy plotted above the free surface of water. So you have the four options for question number 1. So please just try to write your answer based on your understanding, what you have learned in your previous week. Okay, so Bala is telling A option, B option. Okay, total energy measured with respect to datum passing through the bottom of the channel. Okay, nice. Other student, please. For question number 1, whatever you have learned from your previous week 6, so you just try to think on that and try to write your answer, please. Very easy question. Okay, Deep is also telling B option. Nice. Yes, your option B is correct here. That is fine. And what is the meaning? Let us suppose you have the channel like that. This is your flow, water depth, and this is your channel. So this is your channel with very mild slope here I have drawn. Very mild slope. So your surface will also like that little bit. Okay, let me just draw again. Your water surface will also be like that, little bit lower. as slope here, as you see, the here you have the theta slope from the horizontal. Okay, so now what is your total energy? Total energy, as you know from your Bernoulli principle, your datum head, or if I represent with the z, plus velocity head v square by 2g plus pressure head p by rho g. This is your total head. Now this total head, if you are measuring from, this is your datum, if you are measuring from this datum, if this is your z, now what is a specific energy? You are considering datum as a bottom of the channel. This is your datum when you are calculating the specific energy. So here z is equal to 0. Once z will be 0, then your h is specific energy is equal to p by rho z plus v square by 2z, or is equal to y plus v square by 2z. That is your head. So this is the idea. Now we'll see one thing. Okay, so once I'll move on the next question, then I'll explain. So option B here is correct for question number 1. Okay, so let us move on the next question. Here the detailed solution is also given. In open channel, the specific energy is the total energy measured with respect to the datum passing through the bottom of the channel. So very simple definition. Okay. Question number 2. Here the question number 2 is the critical depth for a rectangular channel is given by. So you need to calculate here the critical depth, where Q is a discharge per unit width. Means the unit of Q you have meter cube per second per meter, or you can say meter square per second. So you have the formula Q by Z half rectangular channel, remember please, and B option Q square by Z power 1 by 3. Option C Q your small cube by Z 1 power 1 by 4 Q to the power 4 by Z to the power 1 by 5. So this is the formulas. So here you need to just calculate the formula please. Okay, Bala is telling for B option for question number 2. Q square. Shreya is also telling B option. That's nice. Other participant, please also try to write your answer. Whatever you know. Okay, Deep is also telling. Very nice. Okay, so you know all. That's nice. Good to see. Okay, so the formula for your critical depth is, in case of rectangular channel, remember please, Q square by G to the power 1 by 3. Now one numerical I was solving the GATE 2025. So that time I have seen the question is related from this topic, from your critical depth only. So please just try to solve. I'll just show you here. Question number 42. Here you can see very clearly. Consider flow in a long. Is it visible or not? I think it is not visible. Let me just share. Stop sharing and I'll share again. So hopefully you will be able to see. Now visible? Okay, once I go, yeah, now it is visible, I think. So you have the question here. Consider a flow in long and very wide rectangular open channel. Width of the channel can be considered as infinity compared to the depth of flow. Uniform flow depth is 1 meter. The wet slope of the channel is 0.0001. The Manning's roughness coefficient value is 0.02. Acceleration due to gravity g can be taken as 9.81 meter per second square. The critical depth in meter corresponding to the flow rate resulting from the above condition is. So here you need to calculate the critical depth. So please just try to think and try to solve this question. Okay. So now it will be visible, or let me share in a different way. So maybe it will be, I can also see. I have to share the entire screen only, no option. Then you can see very easily. Okay. So please just try to solve. So you have 5 minutes. After 5 minutes, I'll discuss. Very easy question. If you know the concepts, how you will solve, then very easy. More doubt. Let me see your comment. Yes. Now I can see your comment also. So please just try to solve. Very easy question. 0.3. Deep is telling 0.3. That's nice. I'm waiting for other student also. Anyway, finally I'll explain how you will solve. What but you need to solve, please. Such type of question you can expect in your final exam, gate final exam, as well as you are here just looking. This is your gate 2025. So maybe gate 2026 is already conducted, so you can expect gate 2027 such type of questions. So Deep is telling 0.3 means option B. Okay. Other participant, please. You have four options: 0.4, 0.3, 0.6, 0.1. If it is not visible from your side, just I am try to tell you. Out of four, you have only one correct answer, I think. Okay, Deep is telling using Manning's equation. Yes, you need to use I here Manning's equation because Manning's roughness is given, and acceleration due to gravity, or yes, you know already. The bed slope is also given, and uniform flow depth you have, and wide rectangular channel in the statement is telling. So it indication of you have to use here the Manning's roughness because data is given. Okay, Bala is also telling for question number 42, B option is correct. That is nice. Okay. So now, yes, 0.3 is correct for this question. So now I'll explain for the other students. So, okay. So let me just switch, stop recording, and I'll share again. One. Okay, nice. So now we have the question. Let me just explain you very simple way. Wide rectangular channel you have means your B is very much than Y. Means when you will calculate R value, that is your hydraulic radius, A by T, area by perimeter. So area is your B and Y in case of rectangular channel. This is your B and this is your floor depth Y. Divided by perimeter is B plus 2Y. So this division you can write B only because let us suppose your B is 1000 and Y is 1 meter. Means B 1002. When you will divide something with 1000 and 1002, it will be almost similar. So that's why you can write this B. So the meaning of this more wide, that is wider than your, that is, you can, in the question was written, you can consider the infinity width as compared to your depth. So that is the meaning. So your R will be, BB will be cancelled out. So R will be Y. So this is the idea. This is the main thing for the wide rectangular channel. Now you have to calculate this Y critical depth. For calculating this Q square by G, you need discharge value. Discharge, what is Q? Q is your discharge divided by per unit width. Here it is written, means B, or I'll write the capital B. So what is Q? Q is area into velocity. So now your Q and area is nothing but Y, and velocity is as per the Manning's. Why I am applying Manning's? Because in the question was given 1 by n, r to the power 2 by 3, and r is given y. So y to the power 2 by 3, s to the power 1 by 2, which is slope. Now q by b you can write very easily here, equal to 1 by n, y to the power once 2 by 3 and 1. Let me just 2 by 3 and 1. Power will be 5 by 3. So 5 by 3 s to the power 1 by 2. Now everything in the question is given. So this is your q by b is a small q. So a small q value you will get 1 by 0.02. Y was 1 meter. 5 by 3. S was 0.0001 to the power 1 by 2. So once you will calculate, after the calculation you will put here, and finally you will get for that question your YC will be 0.3. So hope you understand the concept how you will solve. So I'm not here calculating the in detail. You can calculate, just I am telling the concept how you will calculate. So thank you. Now we'll move on the next question for your week 6. Week 6 is okay. Remember please, this formula is applicable only for your rectangular channel, not for other channels. Always remember. Maybe during your solving the question you can apply this formula for other trapezoidal as well as your this is your V type of channel, that is triangular channel, so you cannot apply. Now the next question is, for a hydraulically efficient rectangular channel, again rectangular channel of bed width 4 meter, the depth of flow is. So here you have to remember one thing, we are talking about here the hydraulically efficient rectangular channel. Wet width is given 4, so what will be the depth? So option A is 2. Okay, depth in the meter. Okay, fine. 2, 1, 3 and 4. So you have to just write your answer in the chat box. For question number 3. Just please try to write your answer. Okay, for 3, Bala is telling A option. That is nice. Okay, other student please also try to write your answer. Okay, no issue, I'll just explain you. So remember always please, for hydraulically efficient channel, your bed width should be 2 times your Y, that is depth of the flow. So from here we can you can very easily calculate, this is your Y 4, this is your B which is 4, and 2 into Y, you need to calculate the Y value, very easily you can write 2 meter. So this is the condition, and how you will derive. So sir has explained in the class very well. So you please, I recommend you go through the videos of your lecture week number 6. So option A is correct here. Now we'll move on the next one. Next question is question number 4. Very easy question. For a uniform flow with a depth of 0.5 meter, float number 2 In a rectangular channel, the specific energy will be option A 0.5 meter, option B 0.8 meter, option C is 2 meter, and option D 1.5 meter. So please just try to calculate. Specific, here you need to calculate the specific energy for a given condition. Uniform flow depth and flow number you have 2.0. Okay, Bala is telling D option. Nice. Other student, please also try to write your answer. I am waiting. So, if your fruit number is 2, then what is the condition? Whether this is a critical flow, subcritical, and supercritical. Also, you can write in the chat box the given condition of flow, whether it is supercritical, subcritical, or critical. Okay, Bala is telling supercritical. That is nice. If your fruit number is greater than 1, definitely it is supercritical flow. So now please just you can write the answer for this question as Bala is telling 1.5. The answer for this question, option D. So other student, please also try to write your answer in the chat box. Here we are discussing just if your answer will wrong or right, that it doesn't matter here. Your answer should be correct in your examination only. So please just write your answer in the chat box. Actually, this is opportunity to judge yourself, whether how much you know, and also within this 2 hour you can learn many things, how you will attempt the question and how to manage the time and all, because here I am taking the time more because of just I'm giving to you time for solving the question only, because the motto of this session is the students should solve the question and discuss about the questions and all. That's why I'm giving you time lot. Okay, so other student, please also can write your answer in the chat box if you are able to solve. If you not, I'll wait 1 minute more. If you're not able to, then I'll explain. Okay, so let me just explain you. So here, uniform flow depth you have, that is y is equal to, in the question is given 0.5 meter, and flow number you have is 2.0. Now you need to calculate the specific energy. As you know, the specific energy is y plus v square by 2z, as I have explained earlier in question number 1. Okay, so now y is in the question is given 0.5, and what about the fruit number? Fruit number is nothing but your v by root g d. D. Here I'll write D. And what is D? D is your hydraulic diameter. It is your area by top width. This is not hydraulic radius, remember please. So A is B into Y and top width is B. So again you come up with Y. So here for fruit number you can write for rectangular channel only, because in the question is rectangular channel is given, remember. So V divided by GY. So now we can square root both sides. This is your FR. So when you will square root, so FR square is equal to V square divided by GY. So now you can V square from here. V square is equal to FR square GY. So now you can put here your FR square GY divided by 2Z. So GG will be cancelled out and 0.5 plus FR square means 4. In the question is given to 4 and Y is 0.5 divided by 2. So 2 to the 4. So this is your, the 50% of 2 is 1. So 0.5 plus 1, you will get 1.5. So this will be your final answer. This is your in your meter. So this is your specific energy. So very easy question. You have to understand some basic the basic formulas, then you can very easily calculate. Now we'll move on the next question. Next question, let me just read. Okay. This was a calculation what I was discussing. Okay, the next question, yes, very easy question, very simple. So when the flow parameter at any given instant remains same at every point, the flow is said to be quasi-static, steady state, laminar, uniform. So here you need to understand, when the flow parameter at a given instant remains same at every point, then the flow is said to be, I think I have explained earlier also in the week number 2 3, I don't remember, I am not able to recall the week, exactly week, but I think I have explained earlier, but I didn't remember. Okay, no issue. Please just try to write your answer in the chat box. Okay, Deep is telling option B, that is steady state. Okay. Bala is telling D option uniform. Okay. Here the question is talking about at the given instant remains same at every point. Not we are talking about here the single point. Anyway, I'll explain graphically what is exactly the question. Once I want to see answer from your side, okay? The Deep is telling B and Bala is telling D. Okay, nice. Other student, please also try to write your answer. It's very easy question, please. Just think and try to write. I think what we have solved the your gate question 42. This was your from gate civil engineering 2025 set 2. I think in the set 1 we have also question like that. So I'll check, let me just check and I'll show you. Before that you need to just write your answer for question number 5. And also I'll show you the question number 6 in between. I'll just try to find out the set 1 question, whether any question is related to a sir has completed the hydraulic jump or not, whether sir has completed hydraulic jump. Anyone please write yes or not. Hydraulic jump. Okay, no issue. I think in gate 2020 set 1 2025 the question was related to your hydraulic jump. Okay, no issue. So here the answer for this question is uniform flow. Why? Let me just explain you the difference between steady and uniform. The very simple definition for steady and uniform. So what is the meaning of your, first I'll explain the steady. So let us suppose you have the channel like that. This is your bed of the channel, and flow is like that. This is your flow depth. Now the flow parameters means your depth, velocity, pressure, etc. Now I'll explain with the velocity. So let us suppose I am looking this point. I am looking here. That is point P1. At point P1, at t is equal to 8 am, at t is equal to 8 am, your velocity was 2 meter per second. At t is equal to 8:30 am, your velocity again was 2 meter per second. Only I am looking at this point, particular point P. Maybe at point Q, the velocity was at 8 am 3 meter per second. Here is 3 meter per second. This will not happen, but just for your understanding, I am trying to explain you exactly meaning. But with respect to time at a particular point, your velocity t is equal to 9 am. Again, your velocity is 2 meter per second, and here is 3 meter per second. So this is the condition of steady. We are in the steady condition. We were only consider the at a single point whether your flow parameter is changing or it is constant with respect to time. If at a single point your flow parameter, change in your flow parameter, I'll write f, flow parameter with respect to time is equal to 0, then means no change, that is constant. It means the steady flow. If it is not 0, then unsteady flow. Now what about uniform flow? So again I'll explain in this channel only. Sorry. Okay, so the similar channel. Okay, so now here you have point P, point Q, R, point S, point T. At particular time 8 am, your velocity at all point at P, Q, R, S, T, all point is 2 meter per second. At T is equal to 9 am, at all point your velocity was 2.5 meter per second. With respect to time it is changing, but at a particular time at all point your velocity is same, that is flow parameter is same. This condition is known as your uniform flow condition. In the question is given when the flow parameter at a given instant of time remains same at every point, this is the condition. The flow is said to be uniform, not steady. Remember always please. If it is not same, then non-uniform. If it is not at a particular time, as I've already told you in case of this, steady and non-steady. So hope you understand. Now we'll move on the next question. So this was the basic understanding about uniform and non-uniform. So hope you will always remember. Next question is the critical flow condition in term of discharge, flow area and top width is represented by option A, Q squared T by A GA cube is equal to 1. Option B, QT divided by GA cube is equal to 1. Option C, Q square T GA square is equal to 1. Option D, QT square GA cube is equal to 1. So now please try to write your answer in the chat box. So I am waiting. Okay. So for question 6, Bala is telling option A. That is nice. Other students, please also try to write your answer. Very nice. So, okay, here you need to just try to think about it. So, critical condition in terms of discharge. So, what is the critical condition? You know already the fruit number is equal to 1. So, if the fruit number is equal to 1, so the formula of fruit number you just try to write in terms of discharge. That is only. If you are able to write the fruit number in terms of discharge, that will be your answer. Another way also you can solve your at the critical flow condition, your specific energy will be minimum. So from that differentiation you can also calculate. But we have the easy way, the fruit number in terms of discharge. If you are able to write, then you will get the answer. So please just try to write your answer in the chat box. So as Bala is telling, A option is correct. Q is square T divided by GA cube is equal to 1. That is very nice. So other student, please also try to write your answer in the chat box. Why I am encouraging for all students, as you know, this is a discussion class. So here I'm not going to judge you, and no one going to judge you whether you know or not know. Final exam will judge you whether your university exam or your semester as or NPTEL exam or the GATE exam will judge you. No one going to judge you here. So please, I request again, just try to think and try to write your answer in the chat box. Try to solve. Okay. So I'll wait 1 minute more if you are not able to. Okay, Deep is telling A option. Very nice. Good to see. Okay. Other you please also you can write your answer, whatever you are getting. If you not know, you can Google also. Then you can always remember also. Lot of options are there. So you can go through. No issue. But first you think by yourself. Be honest. If you not know, then you can Google. If you will not honest, definitely it will impact you ultimately. So remember these things also. Okay, so okay. Ghost is telling a option. Very nice. Good to see. Okay, so let me just explain you. Very easy question. So FR is equal to, that is fruit number. Your fruit number V square, V by G into hydraulic diameter, as I have told you. This is not hydraulic depth actually, not diameter. So V by, and what is your hydraulic depth? A by top width. So here you can write G A by T. Now what is velocity? Velocity is nothing but your discharge by area. So you can uh, replace your velocity in terms of discharge. So discharge by area GA by T. Now for critical conditions, now you have to match your result. For critical condition, your FR is equal to 1. Whether this is matching, no matching. So what you will do, you just square root both sides. So 1 square is equal to whole square this. So Q square divided by A square into GA by T. Now I think your answer will match. So Q square and this T will be go nominator side and GA cube. So is equal to 1. So hope this will match. Q square T GA cube is equal to 1. So option A is correct here. For question number 6, option A is correct. So hope you all got it. Now we'll move on the next one. So next is your question number 7. Here the explanation is about as per your the minimum specific energy criteria at critical depth condition. So you can go through it also. Anyway, I'll upload this PDF. So question number 7, the total energy line lies over the hydraulic gradient line by an amount equal to pressure head, velocity head, pressure head plus velocity head, pressure head minus velocity head. So you have to explain, please. Or not explain, you have to write your answer in the chat box. Anyway, so for Bala is telling for question number 7, it is B, that is velocity head. Other student, please also. Anyway, I'll explain graphically what exactly meaning. Okay, other student, please also try to write your answer in the chat box. Velocity head, nice. B option, Deep is telling. Very nice. Okay, let me just explain you what is exactly meaning. So your hydraulic gradient line and what hydraulic energy line. So this is your HGL and this is your total energy line means TEL. So HGL is nothing but this is a combination of your datum head plus pressure head. Means let us assume you are have a channel like that and water is flowing in this direction and this is your bed level. So now HGL and TEL what is? So HGL is here, this is a combination of this is your datum and from the datum whatever you have the pressure energy, that line will show you the HGL, hydraulic gradient line. Let us assume this is showing your the pressure energy. So I'll just, this is HGL. So now and what is total energy? Datum plus pressure plus your velocity head. So your definitely this will be greater than this, so this will be your energy line. Energy line, total energy line. So this is the, what is difference? Difference is v square by 2g only. That is your velocity head. So hope you understand the basic understanding. And whether this line will, this HGL line be aligned with this or little bit above, little bit lower. So this is a different thing. But just graphically, I just try to show you what exactly meaning of, what is the exactly difference between the TEL, total energy line, hydraulic gradient line. Now let me just go on the next question. Question 8. Again you have numerical. So what is Froude's number for a channel having mean velocity 4.34 meter per second and mean hydraulic depth of 3 meter? You have to calculate FR with the given data. So please just try to, I'll wait 2-3 minutes for this question. So this is the calculation. So you just calculate and try to write your answer in the chat box. Very easy question. For 8, Bala is telling A option, Shreya is telling D option 0.4, Bala telling 0.8. Okay. Oh, Deep is also telling 0.8 for this. Okay, nice. Okay, let me just explain you. So FR you know already. This is your V by GY. So not GY, will not write here GY because of this is not a rectangular condition. So D, that is your hydraulic depth. So velocity is given 4.34 divided by root 9.81 into depth is given 3 meter. So only just simple calculation. After the calculation you will get. So let me just see final calculation. Yes, you have 0.8, that is A option is correct. For question number 8, option A is correct here. Now we'll move on the next one. Next is a rectangular channel has a depth 5 meter and width 12 meter. Calculate hydraulic depth of channel. So here you need to calculate the hydraulic depth. The rectangular channel you have the depth 5 meter and the width 12 meter. So please just try to write your answer here Hydraulic depth. As I have explained earlier also, what is hydraulic depth? What is the definition of hydraulic depth? Already I have told you already. When I was discussing the Froude number and all, that is a critical condition. That time I have explained you very well. What is hydraulic depth? This is not your hydraulic radius, remember please. This is your hydraulic depth. So Bala is telling A option, that is 5. Okay. So Bala is telling A option. Other student, please also try to write your answer in the chat box. After that, I'll take 5-minute break so you can also plan. And anyway, I'll show you question number 10 in between. You can solve or you can take 5-minute break also. Okay, so no issue. Let me just show you or let me just solve. Your this depth is hydraulic depth area by top width. I have already told you. In the question is given rectangular channel means B and this is your Y. So Y in the question is given 5 meter and B is given 12 meter. So now what is area? B into Y. What is top width? Top width is nothing but is equal to B in case of rectangular. So you come up with only Y. So your D is equal to Y. So which is 5 meter. So option A is correct for question number 9. Now question number 10. So here the Manning's roughness coefficient N is related to Chase's constant C as R to the power 2 by 3 by C, N is equal to R to the power 1 by 3 C, N is equal to 1 by C, N is equal to R to the power 1 by 6 divided by C. So you have 4 options. Just think on that. If you not know, you can Google it or you can take 5-minute break here. I'm going to take. So we'll meet again after 5 minutes. Yes, you can write also 60 by 12 is equal to 5. No issue. So, okay. So I'll take 5-minute break here. Okay, so for question number 10, Bala is telling option D is correct. That is n is equal to r to the power 1 by 6 or divided by c. Okay, very nice. Anyone can tell what is the Strickler formula for calculating the your n? This is related to your something D50 Strickler formula. If you not know, I'll explain here. I'll tell you. If you know, you can just explore it. If you not know, please you can explore through Google or anyway, I'll write here. That is also important. So let me just explain. Let me just show you the first answer for this question. Yes, for question number 10, your option D is correct here. N is equal to R to the power 1 by 6 divided by C. And what is C? C here is your Chase's constant. Chase's constant. Very easy. Now, uh, one thing is very important. Yes, I was trying to explain you what is a Strickler formula. This is related to your D50 1 by 6 divided by 21.1. This is your Strickler formula for calculating the your Manning's roughness. Okay, so how is this come? This is come Manning's velocity, you know, 1 by n r to the power 2 by 3 s to the power 1 by 2. And what is as per the Chase's c root rs. This is a Chase's equation for calculating the velocity. So c root rs. Now from here, once we will compare, n is equal to r to the power 1 by 6 divided by c you will get. Okay, so thank you for this 2025. Let me just go for 2024. Question is, let me just select the pen. Calculate the Froude number for a channel having discharge 450 meter cube per second. A cross-sectional area of 45 meter square. The top width B. Option A 1.06, option B 0.72, option C 1.75, option D 0.86. So here you need to calculate the Froude number and for given data. Okay, so I'll not go in detail. First you go try to solve, then I'll go in detail. Okay, so please just write your answer in the chat box. I'm waiting for question number first. Your this is 2024 assignment. Very easy. 1.06 Deep is telling. Okay. Option A, it means option A you are telling. Other student, please also try to write your answer. Try to first solve, then you try to write your answer. Because I have already told you, even Bala is also telling A option. So the float number in terms of discharge. So you can very easily calculate. Cross-sectional area is given, top width is given, so very easy. Okay, please, other student, please also try to, okay. So, okay, another student is telling 1.06. At first calculate D is equal to A by T, okay. Yeah, this is the way you can go. Okay, so Deep is telling 0.06, Bala is also telling, and Morukmana is telling 0.0 or 1.06. Deep is okay, suggesting something. Okay, that is nice, very nice. So let me just explain you. So Deep is telling the way of solving, that is very nice. So F is equal to fluid number is equal to your velocity divided by your area, G into hydraulic depth. Hydraulic depth, I'll write first D. So D is equal to, as DP suggests, A by top width. Yes, it is A by top width. And what is here, you can calculate the discharge. Velocity you can write in terms of discharge. So discharge by area is equal to V. So here you can write discharge by area into G A by T. Now you need to put only the and this datas. So A is 45, G 9.81 into 45 divided by 5. So this will be your 5 times, then no, this is 9 times, and after root you will get something more about 9, so I'll something more than 9, so I'll write 9 for the calculation, and this will be cancelled out. So here 10 by 9, so 10 by 9 is equal to 1.0 something. So option A is correct. Not, this is not 75, because once comes 0 then you will go up. Okay. 1.06, or as per this calculation you can go with the 1, then again 1 something, so like that. So it's close to this. Anyway, here I am considering the something you will get, because 9.81 into 9, not exactly 9, it is something more than 9, so you will get this exact answer, no issue. So we'll move again on the next one. So it is your super critical, you know already whether question is asking or not. Not, question is not asking, so it is super critical. Now, very easy question. the fruit number of a flow in a channel section is equal to 1, what type of flow is it? Subcritical, critical, supercritical, truncal. Equal to 1. Very easy question. I need answer from all your participant, all side. Please, I need answer from all participants. For question number 2, Shreya is telling B option. Very nice. Critical. Other student, please. Okay, Deep is also telling critical. Bala is also telling critical. B option. So everyone telling the B option. That is nice. Okay. Yes, when FR is equal to 1, this is your critical flow. When FR is equal to less than 1 or greater than 1, then supercritical. If your FR is equal to less than 1, then subcritical. So this is the this flow classification based on your Froude number. Now question number 3, the critical depth for a rectangular channel is given by where Q is a discharge. This question we have already solved in the previous one, 2025. So we no need to solve here. So final answer will be Q square by G to the power 1 by 3. Next question. In case of open channel, the uniform flow is characterized by a constant slope of channel bottom, a constant depth of flow, a changing depth of flow, a varying slope of the channel bottom. So you have the four options. Try to explain. Try to write your answer in the chat box. First read the question very carefully, all options also. Then you try to write your answer. Question number 4. Okay. Bala is telling B option. A constant depth of flow. Okay, fine. Other student please also. Just try to please write. Okay, so let me just explain you. So here, what question is asking? In case of open channel, uniform flow is characterized by. So as you know, the flow characteristics should be constant throughout the channel at every point, as we have explained earlier also in 2025 said. So this is your flow depth is what? Flow depth is your flow characteristics. Slope of the channel bottom, these are your channel characteristics. Remember please. So option B is correct here. for question number 4. Let me just go another question number 5. Okay, so here answer is visible. So I'll just read and explain you. So hydraulically efficient channel cross section is 1. Question is about hydraulically efficient channel. Hydraulically efficient. Meaning, okay, let me just read first answer options. Which carries maximum discharge under given condition of slope, roughness, flow area. Okay, which has maximum hydraulic radius, which has maximum weighted perimeter, which has maximum hydraulic radius. Okay, so these are the 4 options you have. Now your hydraulic efficient channel, that which carries, here you can see in the option A, which carries maximum discharge under given condition of slope, roughness and flow area. In flow area, these all 3 term is coming. In flow area, it's depend on hydraulic, it's include the hydraulic radius, including what is hydraulic radius. In hydraulic radius already your flow area included. So in the objective type question, you have to go with the most appropriate option, most appropriate. So weighted perimeter also, this is related to your area, and which has the maximum hydraulic depth, because area is nothing but your width and depth. So weighted perimeter is nothing but is the addition of width and depth. That is the this. What is weighted perimeter? These are the, if the flow is up to here, so these are the, this is if y, so 2y plus b, this will weighted perimeter. So in this, everywhere the area is included, so the most appropriate option here is A for question number 5. Let us move on the next one. Here you can see hydraulic efficient channel cross section is one which carries a maximum discharge under given conditions, slope, roughness, flow area. Question 6, very easy question. A 15-meter wide rectangular channel conveys 30 meter cube per second of water at a depth of 1.5 meter. Calculate a specific energy of the following water. Option A 1.24 meter, 1.76 meter, 1.59 meter, 1.94 meter. For question number 6, you just try to solve and then write in the your answer in the chat box. For question number 6, please. Please just try to write your answer. for question number 6, everyone. I'm waiting, please. Okay. So Bala is telling C option is correct for question number 6. Okay. Ghosh is also telling C. Nice. That is 1.59. It means answer is coming. So the questions are very simple here. So only you have to understand some fundamentals about open channel flow and some formulas also. Say Shreya is also telling C option. Okay, so let me just explain you what exactly. 1.529 from the calculator. Okay, 1.529. Maybe some mistake in the typo mistake in the option. Okay, okay. So Deep is telling y plus v square by 2g. Thus we'll go with this only because we are going to calculate the specific energy. Okay, so everyone telling the option C. Let me just go. Let me just see the calculation. You are telling the calculation mistake. Maybe. Okay, maybe the calculation mistake you can consider when you will solve. You can see. I'm not going to calculate here, but I'll tell you the this concept. So here you have the wide rectangular channel. Wide rectangular channel means B is much greater than your Y. So hydraulic radius area by perimeter. So you can write B into Y divided. Anyway, it is rectangular channel. So B plus 2Y. So this you can write Y, B. So your R will be Y only. The rectangular condition means this. The meaning of wide rectangular channel, what why here it is written, because of this you can consider R is equal to the indirectly indication of you consider R is equal to Y only. That is the idea. Okay, so conveys means discharge is given 30 meter cube per second. If anyone not know what the meaning of convey, so you can guess this unit is given for discharge. So definitely the meaning of convey here discharge. Okay, the water depth y is equal to 1.5 meter. Calculate a specific energy. So specific energy is nothing but it is or any wide b is given 15 meter. So y plus v square by 2g. So for v is discharge by area. So what is discharge? Discharge is your 50 30. What is area? 1.5 into 15. Okay, so this is your discharge by area. So here you can put these things also. So let me just 15 to the 30, or this is 20 by 15. So 5, 4 by 3. 4 by 3 means what? 3, 1.33 meter per second. So now here y is equal to 1.5 plus 1.33 square divided by 2 into 9.81. Okay, so after calculation you will get option C. That is, so the option C, it is written 1.59. One student is telling it is coming 1.529. So okay, you can check this typo mistake, so no issue. So but concept overall this, how I will go to solve this question. Okay, so now next question is question number 7. A wide rectangular channel, again wide rectangular channel. So indication is R, you can consider Y, has a longitudinal slope 0.0009 and Manning's roughness has been assessed 0.03. Calculate normal depth in this channel when the channel conveyor discharge intensity of 1.5 meter cube per second per meter. So here you need to calculate normal depth. Why normal? So I'm waiting 5 minutes for this question because the question need calculation. So please just try to calculate. Okay. So everyone telling 1.529. So maybe 1.529 will be the correct calculation. Okay. So no issue. Let us move on the question number 7. So please just try to calculate question number 7. Normal depth here you need to calculate with using the given data. Manning's roughness is given, or longitudinal slope is given, discharge intensity is given. So please just try to calculate. Please just try to calculate. Okay, so Bala is telling A option 1.27. Nice. Okay, I'll wait another 1 minute. If anyone can solving, you can write your answer. Otherwise, I'll explain you. 1 minute more, I'll wait. Such questions, not exactly, but in 2025 set, I have already explained you the concept, how we will solve. Anyway, I'll solve here. After 1 minute, I'll start. Okay, so let me just explain you. So here you have to calculate the normal depth. So what is exactly meaning of normal depth? Normal depth is nothing but the your flow depth in the channel system. So this is the normal depth. So you have the wide rectangular channel, you have data with discharge intensity. So you have to write your equation like or formula in terms of whatever the data is given. So discharge is equal to nothing but area into velocity. And what is area? B into y into velocity. And discharge is here or here, discharge by B is equal to your intensity. Here it is given your discharge intensity y plus v is equal to 1 by n y to the power 2 by 3. Why I am writing the y? Because wide rectangular channel given. So y is equal to, we can write, this is your normal depth, remember please. Now s to the power 1 by 2. So here 1.5 is equal to yn into n value is given already 0.03 into y to the power, where is y? Yes, y and we need to calculate 2 by 3, or I can write, okay, s to the power 1 by 2, which is 0.0009 power 1 by 2. So 1.5 is equal to 1.03 into y to the power 5 by 3 into 0.0009 power 1 by 2. So yn is equal to what? 1.5 into 0.03 divided by 0.0009 to the power 1 by 2 to the whole power is 3 by 5. So this will be your final answer. So here I will not going for calculation. So this is come 1.27. Option A is correct for this. Okay, anyway, here you can see the calculation part. So 1.27. So this is your final answer. Final answer means option A. Option A is your final answer. So question 8, the critical depth is the depth of flow at which the Froude number is less than unity, the specific energy is maximum, the specific energy is minimum, the unit discharge is minimum. The critical depth is the depth of flow at which. Just try to think and try to write your answer in the chat box, please. I'll wait another 1-2 minutes. I'll wait for this question, not more than that. Okay, deep is telling option C, the specific energy is minimum. Okay. Anyway, such type of actually the exact, not exactly the question 8, but related with this we have already solved today, only today in 2025 questions. So you can think Bala is telling C, okay, Bala is telling C, Deep is telling C, okay, means you are telling C option. So yes, C option is correct here. I'll not wait more. So at critical depth is the depth of flow at which the specific energy is minimum. Okay, nice. Now we'll go on the C option is correct here. We'll move on the next question, question number 9. So question 9 is a rectangular channel carries a uniform flow with a fluid number 1.83. The ratio of critical depth to normal depth of this flow is the ratio of critical depth to normal depth. Option A 1.5, option B 2.83, option C 2.0, option D 4.75. For question 9. Okay. So rectangular channel carries a uniform flow with a fluid number 1.83, the ratio of critical depth to the normal depth. Here you need to think critical depth to normal depth. Fr is equal to given 1.83. Another Fr is given which is hidden, the critical depth means at critical fluid number 1. So you have two conditions, Fr is equal to 1.83, Fr is equal to 1, everything is same. So at this condition, what will be the ratio? your critical depth to the normal depth. So I'll wait another 2 minutes for this. Okay, so let me just explain you. So you have the fruit number FR is equal to 1.83. Another you have the another FR, you have FR is equal to 1. So here you need to calculate the ratio of critical depth YC divided by ratio of in normal depth. So these two things you need to calculate here. So now we'll move on the calculation. So here you know already these two things, that is your FR is equal to V by G N Y. Here in the rectangular channel you can write directly your D is equal to Y, as we have already discussed earlier also. So now for rectangular channel, okay, so take both sides square. So when we will take the square both side, FR is equal to FR square, and this is your V square divided by G YN. This is also a square, so it will be V square divided by G YN. So this is. Now what is your critical depth? Critical depth you know already, Q square divided by G to the power 1 by 3. So here you need to, and let me just write in another way, Q square is equal to Z. You can write like that. So here discharge, what is velocity? Discharge into area, and this your velocity is equal to in terms of Q if you want to write. So this is your Q is equal to what? Small q is equal to Q by B. So if you will write Q is equal to B into Y, then you have to write here B and another B here. So Q B square Y. So this will be your velocity. Velocity is Q B square Y from here. So now here you can see this is your, here is directly it is written, okay, or you can write like that, this is your Q by N is equal to B V, here it is written. How? As you know, discharge is equal to what? Area into velocity. So this is your B into Y into velocity. So Q by B is equal to a small q. and divided by y is equal to v. So that's why here it is written q by vn. So we can put here also. So your q square, if this is square, so q square divided by yn square g yn. Now q square by g. Q square by g, you know already, this is y cube we have written here. So y cube divided by yn square yn. So this is yn cube. So now your YC question was asking about critical depth to normal depth is equal to FR. This is your FR square. This was 3 cube. So FR square. Now when you will remove this cube, this will come this side. So 2 by 3. So this is the relation. So hope you understand. And once you will write here your 1.83 to the power 2 by 3, you will find out 1.1. So this was very interesting question. This was very different, you can say the different question what we have solved already. A lot of questions we have solved, but this was a different question. So you can expect such type of question in examination. So okay, that is very nice. Let us move on the next one. So this was 1.5. So option A is correct here for this question. So now we'll move on the next. Next question, for hydraulically efficient rectangular channel, width is 8, the depth of flow is. So please just try to write your answer in the chat box for question number 10. For question number 10, please just try to write your answer. Bala is telling A. We have solved such questions, so no need to waste time here. So already I have told you this is B is equal to nothing but 2y. So y is equal to 8 by 2, which is 4 meter. So option A is correct. Now we'll move on the next one. Yes. The maximum discharge through a circular channel, this is a new question. The depth of flow should be equal to. The maximum discharge through the circular channel, the depth of flow should be equal to. This is your diameter. And this is your y increasing in this direction. So depth of y, the depth of flow should be equal to x time of your diameter of the channel. So what will be the value of x? 1.2, 0.95, 0.8 or 0.6. So what will be the value of x here? Please just try to write your answer in the chat box for question number 11. Bala is telling 0.95. B option, okay? Other student, please. So I have another set of questions 2023. So I'll just show you and I'll tell you the concept. I'll not take much time because we don't have time today. Anyway, I'll just show you the all questions and also the explanation with question. So okay, let me just show you the answer. Yes, option B is correct. It should be 0.95 times, not completely filled. For maximum discharge through circular channel, the depth of flow should be equal to 0.95 times of the diameter of the channel. Next question. Oh, sorry. Next question here you can see, in definition of Froude number applicable to a channel of any shape, the length parameter used is the depth of flow, hydraulic radius, ratio of area by top width, weighted perimeter. We have already solved such questions. So this is your mm, y is equal to area by top width, or we have already represented with d. All this is d. In the question is represented with y. No issue. So always remember, please. So here option C will be correct. Area by top. Now we'll move on the assignment. That is your 2023 question. So here I'll explain you one by one. You no need to solve here. So you just try to see. Calculate the Froude number of channel having the discharge this much and cross-sectional area 42 and the top width being 6 meters. So here you need to calculate the Froude number. So the similar question we have solved here. You can see very clearly the similar question. Only the digit is different. The numerical digit is here 300, here 450. So no need to solve. Question number next. The Froude number is equal to 1. We have already solved. Next question. Here the explanation is given. You can see very clearly. Next question is an open channel flow. An open channel flow is one in which, this is question is new question, the solid boundaries confine the flow are open at the top. The solid boundary confine the flow are open at the top. The liquid flowing in a closed conduit has a free surface. A closed conduit is full of flowing liquid, none of the above. So here the for question 3 or option B is correct. The liquid flowing in a closed conduit of has a free surface. Okay. Next question. In case of open channel, uniform flow is characterized. Already we have seen. Next question. The hydraulically efficient channel, already we have seen this question. A 12-meter wide rectangular channel convey 20 meter, already we have solved this question. So most of the question we have already solved. A wide rectangular channel has longitudinal slope is this, Manning's roughness this, and calculate the normal depth, already we have solved. So most of the question is repeating in the question number 3, question number 23. 2023 and 2024, as you can see here very clearly, only digit is different. So no need to solve again. You can attempt for your this revision. A uniform flow in open channel exists when the flow is steady, and here this is a new question. The uniform flow in an open channel exists when the flow is steady and channel is frictionless, channel is non-prismatic, channel is prismatic, channel is prismatic, and the depth of flow is constant along the channel. So here option D is correct for question number 8. Now question number 9. So a rectangular channel carries a uniform flow with a Froude number 2.83, the ratio of critical depth to the normal depth. So similar thing here. What we have already solved, your Froude number is equal to V by Gy. So FR square we have already solved. This is Q by Yn, nothing but your, and Gy. This is square. So here you can very easily think. Just solve. Just a few minutes back we have solved already. Okay, so next question. Question number 10. A hydraulically efficient rectangular channel bed width for the depth of the flow. We have already solved very easy question, that is 2 meter. Okay, for question number 11. I think this is a new question. Let me just read. A rectangular channel 3 meter wide is laid on a slope 0.0002 when the depth of flow in the channel is 1.5. What is the average boundary shear stress? This is the new question. You have to calculate the average boundary shear stress. So if anyone want to attempt, okay, no issue. I'll just show you what will be the average boundary, how we will calculate a rectangular channel you have. Let me just explain you graphically, then you can feel understand. Though here you have the 3 meter and the slope of the channel is 0.002002, and when the flow depth in the channel is 1.5, so this is 1.5 meter. Then what is the average boundary shear stress? Nearly these are the boundaries. So what will be the average shear stress? So gamma rs here will apply. Let me just show you the formula. This is your gamma rs. Gamma is what? The unit weight, that is 9 point unit weight of soil, unit weight of your this water. So 9.81 kilonewton per meter cube. So in the Newton 9.810, and your R value is what? You can calculate R value is area by perimeter, so which is comes 0.75, and slope is already, you know, already in the question is given. So 1.47. This was the new question. Remember always, please. Next, in the definition of road number applicable to the channel of any shape, the length parameter is used. Already know. Area, ratio of area to top width. So now we have already completed question number, your assignment 6, 2025, 2023, 2024. So hope you all understand and hope you all enjoyed this session. So we'll meet again in the next class on the next Sunday. Thank you. Thank you, Bala. On 8 March. We'll meet again on the 8 March. So thank you. With the new questions, week 7. So now you can leave the class. Okay, thank you. Thank you, Deep.